I'd like to welcome Dr. Yi Zheng. He is an associate professor in grain science and industry at K-State. He is a 2021 GFS Seed Grant recipient, and his project was titled Developing a Distilled Alcoholic Beverage Program Utilizing Grain Sorghum Associated with Coproducts Valorization. Dr. Zheng.
Yeah, thank you, Jay. Again, I'm Dr. Yi Zheng, Associate Professor of the Grain Science and Industry Department. And our team include Dr. Yonghui Li, Associate Professor of Grain Science Industry, Dr. Gordon Smith, Professor of Grain Science Industry, and Dr. Donghai Wang, Professor from Biological and Agricultural Engineering. So our project is developing a distilled alcoholic beverage program utilizing grain sorghum associated with coproducts valorization. So first of all, I want to give a brief the background information about this project and the goals and objective. And then I will describe in detail about our approaches that have been used to carry out this project. And then I will present some results and discussion from this project. And at the end, I will summarize the key findings of this project and propose some future work. So as we know, grain sorghum actually is mainly resistant to adverse conditions, for example, drought and high temperature. And compared to corn and other crops, so sorghum actually required really much lower input, including water and fertilizer. And so sorghum can be grown in marginal land. Okay, and sorghum actually is the top 3 cereal grains in the U.S. Kansas State is #1 sorghum producing state. So that's why if we can find the higher value application for sorghum, so it will advance the economics of the Kansas and the U.S. So for applications, existing application including the animal feed, and a little bit sorghum is used for food production, especially for gluten-free. And recently, about 40% sorghum actually is used to produce ethanol as a transportation fuel for the marginal profit. But now we are trying to looking for the higher value application. For example, it can be used to produce the alcoholic beverage, for example, the baijiu in China, and also the gluten-free whiskey, and antioxidant and fiber, that kind of a higher value application. But this kind of higher value application is seldom in US. So that's why we can see there are actually lots of potential the market and high value the outlets for the sorghum for domestic and international market. So this slide is showing you that alcoholic beverage revenue by the alcoholic beverage type. So as we can see, the market actually increased a lot, okay, especially after the 2020. So the market value in US is about 1,664 billion in 2002, and it's keep increasing at a rate about 6.78%. And also, this figure is showing the price of different alcoholic beverage. So look at the top yellow curve. Actually, that one is the price change of the spirit. So including the whiskey, vodka, that kind of the liquid. So you can see the price increased a lot, especially after the 2021. And actually, the price and the increase rate actually is the highest among all the alcoholic beverage, right? Compared to beer, wine, those kind of. So that's why we can see there's lots of potential for the alcoholic beverage from sorghum. And also this slide is showing the top 5 countries that have the highest revenue from the alcoholic beverage, including China, US, Japan, UK, and Germany. So that's why if we can convert sorghum into that kind of alcoholic beverage and export that kind of the beverage as a product. So instead of the export sodium grain as a free stock, it's no value, right? So the alcoholic beverage, of course, have a much higher value than grain itself. Okay, and this figure is again showing. So among all different type of spirits, including baijiu, brandy, whiskey, vodka, that kind of spirits, baijiu has the highest value, actually much higher than combination of all other 5 liquor. So, for example, the global value for the spirits is 521 billion in 22, and China actually has 156.8 billions. Okay, especially many in the baijiu. Okay, so and in addition to the baijiu in China, and baijiu now is gaining popularity outside of China. For example, in US, European country, in Australia, so more and more people starting accepting that the baijiu, because in not time ago, so people does not accept that much, that because the flavor is totally different from whiskey and brandy, gin, that kind of the spirit. Okay, but that's a good thing. Actually, give us kind of information that we could produce a sorghum-based baijiu here to accommodate the local demand, and at the same time, so we can the export the extra to other countries to make a bit more profit. Okay, so based on the composition of the sorghum, so we can see the starch. So the flower, the endosperm, this major component is starch. So that can be converted to the spirit, including baijiu, vodka, whiskey, and that kind of alcoholic beverage. And after that, we got residue, which is called DGS, dry distilled grain. So as we know, the grain contains the starch, which is a major, right? Followed by the protein content. This is the second major component. So after the starch is converted to the alcoholic beverage, we got lots of the concentrated protein left. So that protein usually is used as an animal feed. So by animal feed, value is low. It's lower, right, compared to the other protein-based product. So that's why we want to convert that DGS into plant-based protein for higher value applications. So from this slide, we can see the plant-based protein actually gains more and more demand and more the attention and interest. Okay, because the animal protein now, it's kind of a that's a kind of bottleneck, because to produce the animal-based protein, it has lots of impact on environment, right? The air and water and soil, that kind of pollution, right? And also the animal-based protein usually has a high cost. So that's why more and more people are really interested in to kind of explore the product from plant-based protein. And also people really expect that plant protein can replace, at least partially replace, animal-based protein. So as you can see here, the requirement of then the demand of the plant-based protein actually increased a lot, almost linear, right, from 2020 to 27. And most of plant protein now are from soybean, wheat protein, pea protein, and others. Okay, but still, so we need more and more protein. That's why we need to find maybe more plant-based protein resource. So sorghum and other type of grains could be the plant-based protein source. So, and you can see here in the market now, plant-based protein have been used for many applications. for example, dairy substitutes, meat substitutes, drinkable meals, seafood substitute, that kind of thing. And also there are many companies now invest, or they already have the product, plant-based protein product available there. So that's where we can see there's many potentials, for plant-based protein. For example, sorghum protein, right? And we do have some industry partner who contact us to express their interest in in future collaborations. Okay, but it really depends on how our project goes, right? So, for example, if we have findings and lots of really high-value application and economic feasible applications, then yeah, we can reach out to them to develop the future collaborations, or for example, the technology transfer, licensing, patent, that kind of thing. Okay, this table is showing the amino acids profile of different cereal grain. For example, the sorghum has higher leucine and the adenine, so compared to the other cereal grains. Okay, so that could give us some special applications or the nutritional value of the sorghum. But not much research has been done on this, so that's why we're interested in that. And more amino acids. So we find out that hydrophobic amino acids of sorghum is much higher than the other grain. You can see the second row, it's much higher than that. And then the ratio between hydrophobic and hydrophilic amino acid, or the sorghum, is 1.1. It's higher than others, close to corn. But this could tell us the sorghum protein could have some unique application. For example, we can convert the sorghum protein to some packaging material for food. Okay, edible packaging material, right? And then we don't need to use the plastic for the packaging, right? So and it could be environmental friendly, so material. Or the hydrophobic amino acids could be used for other food application, but we don't know. There's no such research has been done. So that's why that really attract our interest to go further to do more research on this. Okay, so based on the background information, so we propose a long-term goal, short-term goal, and objective. So the long-term goal is to develop and establish a new research and education program at K-State to produce sorghum, DAB, distilled alcoholic beverage, and valorize the co-product. For example, distilled grain with soluble, DGS, for the value-added utilization. For example, the antioxidant applications. And also for sorghum, sorghum actually has the really high phenolic compound there, which is really good. The high value antioxidants. So we did a little bit that kind of study too. And the short-term goal is to implement a proof of concept on the DAB production using the starch component, okay, and the antioxidant extraction using the protein of grain sorghum. Okay, to achieve this short-term goal, so we proposed the 4 objectives. The first one is to characterize sorghum and study saccharification of sorghum. And second is to study alcohol, beverage, fermentation, and distillation processes. And third is to explore value-added utilization of DGS to produce antioxidants. And last one is to foster the future food system workforce while student training. And then I will give an introduction about the approaches we use to implement that objectives. Okay, so we actually obtained the 7 different varieties of sorghum from a company called New Knife Market, which is a sorghum company. Okay. So and we divided that 7 variety into 3 groups based on color. So the first white color has 3 different variety, and red color has 3 different variety too, and 1 black. Okay, we have 1 variety there. And we use two different fermentation technologies. One is liquid fermentation. Okay, so and in the liquid fermentation, we use 4 commercial yeast strains, which are common yeast strains that have been used to produce the spirits. For example, the vodka, spirit, gin, and that kind of spirit. And the second method for fermentation is called solid state fermentation. So we used 10 different cultures to do that kind of fermentation. The first culture actually is called xiaoqu, which is the kind of mixed cultures that is used to produce baijiu in China. So we bought this from Amazon. And we also tested another 9 yeast strains. This strain provided by a company called Fermentis. But we don't test the yeast individually. We actually mix this yeast each with the xiaoqu. So basically, we have 10 different mixed culture. Okay. All right. So and also we got because we got 7 different variety of sorghums. So we do the characterization just to identify the chemical compositions, chemical properties, physical properties, and the thermal properties, because those kind of the properties can guide us for the fermentation process. Okay, so for example, we measure the starch component, and that can give us the kind of a yield calculation, right? We can know how much ethanol can be produced from that starch. Okay, we can calculate the theoretical yield, and we can have the practical yield, and then we can calculate yield, the yield, and then from there we can calculate the economics, right? And also we measure the protein content. Okay, and then that can give us then the kind of idea if that protein can give us the economically feasible protein product, right? If the protein content is too low, then maybe no meaning to do that. And fiber, fat, tannin, aminos, and ash content. And also we measure the starch gelatinization temperature, because that can tell us what's the temperature we need to use in the liquid fermentation. Right? And also we measure the viscosity. That is useful information to guide the liquid fermentation too. And we measure the protein digestibility. Okay? And we measure the physical property, including hardness, density, diameter, and so on. Okay, so again, in the fermentation, we tested 4 different strains of yeast, and those are pure yeast, which are used to produce the really popular spirits in the market. Okay, and this table showing that all the cultures we used for solid fermentations. Can you see we have 9 pure yeast, but they were not used just individually. They actually mix with the xiaoqu. Okay, so we actually tested all the mixed culture, and the control is the xiaoqu. So which is also a mixture, but it includes bacteria, yeast, and some fungi. All right, the procedures that liquid fermentation used include flour production. Basically, we just milled the sorghum grain into flour, and then we do cooking. Okay, just to liquefy the starch. And then we add an enzyme there to do the saccharification, because those enzymes can degrade the starch after the liquefaction. Okay, and starch will be converted into sugars. And after we get sugar, we can inoculate the yeast over here. Okay, and the yeast can initiate the fermentation process. And after fermentation process is done, we do distillation, okay, to concentrate the alcohol to produce that spirit. Okay. And at the same time, we get DGS, right? Because some residue there. Protein, most of the protein is not consumed. And also we got some other residual fiber, ash. So there's some components. And those kind of DDGS will be harvested and used to produce the protein. Okay. And this process, the image actually the processed we use to do the sonic fermentation. So for sonic fermentation, we did not do milling actually. We handled the whole sorghum kernel, whole sorghum grain. Okay. First step, we do soaking. Okay, washing, cleaning to remove foreigners. Okay, foreign material. So and after that, we soak the sound, clean grains into the water, in water. And probably it depends on what kind of sorghum, okay? So and then the soaking can last 24 hours, the whole day, okay? And after the soaking, so we use the high temperature cooking. So and sometimes people use a steaming process. The purpose is to open the bran, just to break up the bran and the surface of grain and explode the starch, okay, to the following the liquefaction, saccharification, and the fermentation process, okay. But in the sonic fermentation, we did not use the enzyme, right? That actually is used during the liquid fermentation. Again, we use mixed culture here. In the mixed culture, some microorganisms are responsible for the saccharification. So they can generate the enzyme, and that enzyme can degrade the starch into sugar. And some microorganisms are responsible for fermentation. So they kind of work together synergistically. Okay, that is the difference between solid state and liquid fermentation. Okay, and after that, we also do the distillation. Okay, just to recover the alcohols from the fermentation broth. Okay, and after that distillation, we need to do aging. Okay, just to give sufficient time to the product, okay, to the fresh beer to develop the flavors, okay? And that usually aging takes months, years, or even 10 years, or more than that, okay? So of course, longer is better, okay, for the spirit, okay? All right, so in the solid stage fermentation, we do two different experiments. The first experiment is about the sorghum variety screening. Again, we have several varieties. In this variety screening, we use only one culture, 小曲. Okay, so the picture here showing the first one is showing the raw grain, and the second one is showing the grain after cooking. Okay, and you can see nuts of grains are the crack, right? And you can see the white starch already explode. Okay, already explode. This is the purpose why we need to not have cooking. And after that, we inoculate the culture, okay, mixed culture culture. And again, you can see the third in this picture is showing the white, the kind of phenom, okay, there's fungi, the phenom, okay. So that tells us the liquefaction and saccharification process went well, okay. And after that, about 2 days. So after that, we moved the saccharified the grains into fermenter. So the fourth picture. So that and then the fermenter is covered by the air lock. Okay, air locker. So we use the liquid air locker. Okay, and then the fermentation will happen under the anaerobic condition. Okay, and after months, really depending how the fermentation process goes. Okay, so we take the sample periodically until the alcohol concentration stay constant, and then we can stop there. Okay, and after that we do the distillation. This is a distillation tower. Okay, the cooling tower here, and this is the kettle. Okay, this is a cooling tower, and this is a receiver here. When we connect the distillate, and then do analysis to monitor the ethanol concentration. Okay, and here we got the distillate in the gas bottle, and at the same time we got some the DGS. Okay, so that will be dried and used for the protein extraction. Okay, for protein storage. And that's the first experiment. And the second experiment is about the fermenting culture screening. So we want to find out maybe the kind of the best, okay, the cultures which can give us the highest ethanol the yield. Okay. All right, and in this culture, the screenings, we tested 10 different cultures. Again, the Xiaoqi control, and also we mix other yeast with the Xiaoqi. And in this, the experiment, we use 3 different varieties. Okay, based on the result from the sorghum variety experiment, we picked these 3. Okay. All right, and to evaluate the fermentations, we measure the dextro equivalent. Okay, that actually tells us liquefied results, especially for liquid fermentation. Okay, because that the liquefied result directly affect the fermentation process. Okay, and during that the liquefaction process, we measure glucose, maltose, maltose, that kind of sugar, to kind of monitor that liquefaction process. Okay, all these 2 steps are used in liquid fermentation. Okay, but during solid fermentation, we did not do that. Okay, and at the end, and during the experiment, we measure the ethanol concentration and we calculate the ethanol yield. Okay, and eventually we also measure the flavor compound, because that the different the spirits, they have a really big difference in the flavor compound. Okay, that tells the difference between the spirit. Okay, and that difference can be caused by the sorghum variety, caused by the fermenting culture, and caused by the processing. Okay, so different the brewery, they may use a different operation process, unit operation, that can cause the difference too. Okay. All right, and after that, we use a different method to extract the protein from DGS. Okay, we tested alkaline method. We also tested the yeast method. Okay, and after we got that, we measured the antioxidant activity, and also we identified the peptides, which is from the sorghum protein. And from there, so we will have the kind of idea to study the application. Okay, so from the peptides and the antioxidant activities, and from the peptide structure, then we can have a clear idea what kind of potential application we can use that protein for the hybrid application. Okay. All right, and this slide is showing the polyphenol extraction. Okay, the same thing. We started from the DGS and used the solvent. For example, we use the acetone, we use the ethanol, we use the isopropanol, that kind of solvent, to extract the polyphenol from the extract. And then we studied that structure and composition of the kind of extract. And also in the future, we're gonna study the antioxidant activity and identify the potential application. And all right, so result, and this table is showing the physical properties. So we measure the kernel hardness, kernel weight, diameter, and the test weight kind of thing. So from here we can know lots of information. For example, the diameter. So as we know, when we do the solid state fermentation, right, we use cooking, but that cooking process is actually affected by the grain diameter, because the cooking process basically just the heat diffusion process, right? And then that heat actually carried by the water. Okay, so that means the size, the kernel size determine the distance for diffusion, right? So if the distance is too large, that diffusion will be slow. So that means we probably need to spend a longer time in cooking, right? For the sorghum, the grain cooking, right? So that actually affect the process efficiency. Of course, it affect energy costs, eventually affect the economics. Okay. All right, and this table is showing the chemical composition. So we care about the starch, protein, fat, and so on. And you can see that starch actually can really affect the yield, right? Because the alcoholic beverage really produced from starch, right? And also protein, it can determine that yield, right? And the last column is showing the tannin. And we can see here the last two rows showing the red and black sorghum. Their tannin components are really high. One benefit for high tannin is eventually we get really high polyphenol yield from the sorghum DGS, right? That's a good thing because we get higher value product out of it. But one disadvantage of the tannin content is this tannin may inhibit the fermentation process. As we know, some yeast are really sensitive to the tannin. Okay, so that's why we want to do test the different yeast and test the different variety. Okay, and see how the variety, how each the strains affect that fermentation efficiency. Okay, and this figure is showing that the viscosity change with the temperature, and the dash line is showing the temperature profile, and the solid line with a different color is showing the different the sorghum. Okay, and from here we can get some information. Say, for example, when we do the liquid fermentation, so we need to cook the starch, right? But we don't boil it. So it really depends on the temperature information from here. So we just decide what is the temperature we use to do the liquefaction, and what is the temperature we use to do the saccharification, right? So, and that kind of information is really important for the liquid fermentation. Okay? And all right, this the top two tables here is showing the alcohol concentrations from different the sorghum and from different the yeast strain. Okay, so and then the middle table is showing the alcohol yield. Okay, as we can see, the yield is pretty close, but this one actually has the highest yield. Okay, ethanol red, this is a one yeast strain, and the red sorghum, white sorghum, and red sorghum. So this that means the yeast strain, this one ethanol red, could give us the highest, okay, potentially. And from there, we do the statistic analysis, and we find out actually each strain is not significant actually for ethanol concentration or yield. But sorghum variety actually is significant here. From p-value, it's much lower than 0.05. So then we can see for that, we can conclude for the liquid fermentation, the sorghum variety really affect the ethanol yield and the concentration. Okay. All right. So, and we also analyze the flavor compound of the liquid fermentation product. So as we can see here on the table on the right side, so the sorghum, okay, is a sorghum and yeast and interaction between sorghum and yeast. So they actually have different effect on different flavor compound. Okay, for some flavor compound, for example, the one propanol, so sorghum variety is not significant, but yeast is. Okay, but for the second methyl isobutyrate, so sorghum and yeast both are insignificant. Okay, but for other flavor compound, both sodium and yeast are significant. And the bottom heat map is showing the richness of different the flavor compound. Okay, and the red color is showing the highest richness. As we can see here again, so the product from different variety of sorghum and different yeast, and they're really different. Okay, so again, that means sorghum variety and yeast really affect the flavor compound. That is why we need to do the screening. Okay, and in the future, we're going to do the sensory test to see which flavor profile actually attract more, customers. Okay, but in this part, we did not do the sensor test, but that's a really important step we have to go with. Okay. All right, and that's all about the liquid fermentation. And then here I'm going to talk a little bit about solid fermentation result here. Okay, this table is showing the result from the sorghum screening, and the second column is showing the ethanol concentration of the fermentation broth. Okay, it's raw broth actually, and we can see there's a varied a lot, right, from sorghum in between different sorghum variety, and this is the distillate. Okay, so after fermentation, we distilled the product, distilled broth, and concentrated alcohol. You can see here. So this had meaning the first about 10% of the total. So you can see concentration is really high. So usually concentration higher than 50% means really good quality, really good product. Okay. So for the baijiu, so the highest ethanol concentration meaning high quality. Okay. And this is showing the midstream. Okay. We connect the distillate separately. We connect the head distillate and the May Street distillate. And you can see May Street has about 30 to 40%. But this one probably need to go the second round of distillation, meaning double distillation, in order to achieve a higher concentration. Okay. And this table is showing the flavor compound profile. So it's pretty simple, right? So not so many the flavor compound as expected. So probably one reason is because we use the GC-mass method. So this method may not be able to detect all the flavor compound compared to literature. That's why we trying to find out other methods, GC-mass with headspace. Okay, but I'm gonna give a little bit information later in the end. Okay. And here you can see that again the different varieties have different flavor compound, right? Again, so for example, red and 16 give the most the flavor compound, right? Okay. All right, and this is three tables showing the fermenting culture screening. So compare, and here we use three variety of sorghum, okay, and for all the culture. So overall, we can see, so this red waxy give the highest ethanol concentration, and followed by the white 45-25 and the red NMSB, okay? So again, so from these tables and from this comparison between them, so we can see the variety, sorghum variety and the yeast really affect, and the culture really affect the ethanol, the yield, okay? And this is showing the different, flavor compound profile for the different combination of sorghum variety and the culture, okay? So as we can see here, RM5, 9, and RM6. Here, this one, red, the sorghum. So it gives us the maximum flavor compound, okay? So compared to others. So that means that lower yield does not mean bad quality, okay? It just means yield itself, right? So but this here, flavor compound sometimes give better quality, actually. Okay, so when we taste the alcoholic beverage, we usually judge the quality based on the flavor, actually. Okay, so and the red sorghum, because it has lots of the tannin compound, right? And that kind of phenolic compound give us this kind of this flavor. So that just the hypothesis. We're gonna do more the test, okay, to prove that hypothesis. And this is a better identification methods to characterize the flavor compound, as I mentioned that. So we add a kind of headspace to GC. That headspace can extract more flavor compound from the result. That's why we get much more flavor compound from the distillate. And in the future, we're going to do more because here we got many other peaks Okay, they're unknown peaks, but they should be something, should be some flavor compound, but we need to do more research there. Okay, and then after that distillation, we connect the DGS and we do the protein extraction. Here we tested the alkaline. Okay, we tested the acids, we tested enzyme, different enzyme, and we can see here recovery. So the enzyme actually extraction gives us the best result for the yield and the protein recovery, right? And here we tested the protein, the antioxidant activity, okay, by the emulsification test. And from the first figure, we can see the addition of this peptide does not affect the emulsion turbidity. Okay, it really it does not affect. Doesn't matter the dose. Okay, 50 or 100. Okay, control meaning no antioxidant, no peptide there. But if we take a look at the antioxidant activity, the blue curve is showing the control. Okay, and you can see this oxidation actually happened a lot. Okay, that's not good, meaning the product actually is oxidized. But if we add this kind of peptide from the sorghum, then see that during 14 days storage, so that's no change. That means the product actually is protected from oxidation very well. Again, the T-bars. This is another criteria to measure the oxidation process. Again, so the peptide can protect the product really well. And here, picture is showing the comparison between control and the emulsion with antioxidant, which is the sorghum peptide. So there's not much change actually. That's just little. Okay, and we also use this sorghum peptide to protect the meat. Okay, and compare this is the control. The blue line on top is showing the oxidation, and this in the bottom line is showing the commercial of the antioxidant. But our peptide stay be in between. So that means that's good. Actually, the peptide can really help, okay, to prevent the meat product from oxidation. Okay. All right, and this table is showing the phenol polyphenols we extracted from the DGS. Okay, there's many different type of phenolic compound there. So, but now we haven't identified their the properties and the quantities and the application. So we're going to do that in the future. Okay, so other results actually from this project, we submit the proposal to a commission. Fortunately, we got funded. Okay, this is a 2 years project. That's a good thing. So, and the second proposal we submitted to sorghum checkout. Okay, so the proposal is still under review. Okay, and we have one publication and other two publications, other two manuscripts under the review. Okay, and we had the one presentations, okay, at the IFT, and so for the fourth objective about the student and the working force, the development. So in this project we had one postdoc, and we had the 4 graduate students, and we also hired 1 undergrad student. Okay, so that means that we have a pretty good the team, and we have really good the training, the task finished. Okay, and the conclusions, the first one, we identified the sorghum variety and culture, right, which are suitable for DAV based on the yield. Okay, it's not based on the flavor compound. And also we identify the optimal conditions for saccharification and fermentation, okay, to achieve the maximum ethanol yield. Okay, and also we found that the sorghum variety and the fermenting culture really affect the alcohol yield and the flavor of the distilled alcohol beverage. And also we determine the characteristics, functions of protein, and the phenolic compound. Okay, and also we recruit graduate students and postdoc. Okay, so and also we the project really attract potential the industry interest. Okay, and some future work. But first, we're going to further improve that fermentation process, for example, aging, because we did not finish aging yet. Because again, aging usually take a month or even. And then we're going to do that, follow up that with the aging process later. And culture development, okay? So the culture is really, really important for the yield and then flavor compound development. But here we just use the xiaoqi. That's really, really kind of really common. It's not really special, right? But we will even in the future we want to develop our own cultures to produce maybe different alcoholic beverage to accommodate different customers. Okay, and then eventually we're going to do sensory test. Okay, just to really tell which the type of product meet what kind of customer. Okay. And then we're going to do more the study on protein and phenolic compound, especially identifying applications. Okay, and also we're going to establish the alcoholic beverage and fermentation program. For example, we're going to develop courses. Okay, and then the certificate program. Okay, and we will keep trying the submitting a proposal for more funding for the support to do the more work. And then the ultimate goal, we're gonna commercialize our product, okay, either through the licensing or through the companies, okay, so we can establish our own company here. All right. So with that, I really appreciate the funding result from a Global Food System Initiative, which is located housed in Kansas State University, and we'll also thank a new night market company for providing the green sorghum sample, and also we want to thank Fermentis, the company who provided us the yeast for the fermentation test. Okay, thank you. That's all about the project for the alcoholic beverage production.
And I'd like to encourage anyone, if they have questions or want to learn more about this project and this work, to reach out to Dr. Zheng about that.